1 2 1 3 2 3. Okay, this is discrete topology. Okay. I hope that you understand the discrete topology and trivial topology. Salam alaikum. Discrete topology and let x be natural number n. 1, 2, 3. Okay. Tell me that tau is a subset of n that is finite. A is finite. Okay. Union with b and x. Tell me that is tau a topology on n? Okay, please think on it and tell me that is it topology or no? I check that if tau is a topology or no. First of all, you say that phi and x belong to tau. Okay, phi and x belong to tau. The first condition is whole. Okay, I check the second condition. R1 and R2 belong to tau. Is R1 intersection with R2 belong to tau? Okay. R is finite. Okay. Elements of tau is okay. Understand. The elements of tau is finite. Okay, finite. R finite, R finite. Okay. The intersection of two finite set is finite. Okay, is finite. Then R1 intersection R2 belong to tau. Okay, the second condition holds. Now we check the final condition. Okay, let Ri belong to tau. Okay, R alpha. Is there union of alpha belong to tau? Is it whole? Okay. For example, R1 is 1, R2 is 2, finite sets. Okay. Rn is n, et. Okay. you see that they are belong to two. Belong to two. Okay. Then union of I. Union of I. 1, 2, 3, N, and 8. Okay. You see that this is I start with 2. I start with 2. 2, 3, 4. Okay. This is indeed equal to n minus 1. N minus 1. Okay. But this is not finite. Is not finite. Then their union is not belong to 2. Is not belong to 2 because are must be finite. Okay, but this I call union of alpha. Alpha belong to pi. Okay, is not finite. Is not finite. Then it is not belong to 2. Then it is not belong to 2, and topology this condition does not hold. Does not hold. Okay. 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 The third condition does not hold. Then 2 is not topology on N. Everybody understand? Everybody understand? Hello, everybody understand? Okay. تشکر قسطان الحسناوی حسن زایر محمد الخفاجی عبدالسلام Taha. Understand?
نعم أستاذ.
Salam alaikum.
أستاذ عليكم السلام أستاذ عبد السلام محمد طه.
Teşekkür. Şükran cezila. Abdussalam Taha. Understand what I say?
شكرا شكرا دكتور.
Şükran. Şükran. Okay. Okay. A theorem. I give a theorem here. Let X be a infinite set and to be a topology on X. Suppose that every non-finite, infinite, okay, infinite subset of X belongs into, then tau is equal to AX. Discrete topology. Discrete topology. I must show that tau is a discrete topology. Okay. We know that every topology is in Px. Okay, we know that Px is very large with respect to all topology. This is whole. We must show that Px is a subset of tau. Okay, is a subset of. We show that Px is a subset of tau. Excuse me. Tau. Tau. We show that if, for example, R belongs to Px, then R belongs to tau. Okay, this is what I must prove. Okay, we know that every infinite set has a countable subset. Okay. For example, you know that R is a infinite set, Q is a countable set. Okay, countables. For example, okay. Okay. Then X has a countable set like R. For example, R is R1, R2, R3, and with countable set of X. Okay, countable set of we discrete the even and odd now. Odd. Okay, elements of X. Okay, we give I write we divide X to even and odd elements. of O. For example, P is O1, O3, O5, and C is O2, O4, O6, and 8. Okay? Then O is A union C. A intersection with C is empty. Okay? This is trivial. Now, let T be a elements of Kx. We must show that T belong to tau. Okay, we like to this one. Okay, we have two cases for T. One, T is infinite. Two, T is finite. Okay, if T is infinite, I come back to that every infinite subset of X belongs to tau. Every infinite subset of X belongs to tau. Okay, then belong to tau. Proof is done. Proof is complete. Okay, this is trivia. Thus we suppose that T is finite. T is finite. Okay, T is finite. What happened for this case? In this case, let I call it D1 as a B intersection with D. Okay, D2 I call C intersection. C intersection with B. Okay, B is here the odd elements of X are, and C is the even elements of R. Okay, T is belong to Px. Okay, A is belong to Px. Then T has an intersection with B. T has an intersection with C. Okay, I call the intersection with B is D1, and intersection with C is called D2. Okay, we see that D1 intersection T2 is D. Okay, it is trivial. Okay, A and C is infinite. As you see, A and C is infinite. Okay, you see that here. A is infinite, C is infinite. Okay, A is infinite, C is infinite. A and C is infinite. Then D1 and D2 is infinite. Again, every infinite subset of X belongs to 2. But 2 is a topology. Then D1 intersection D2 is belong to 2. Then D belongs to 2. D belongs to 2. This is complete OR proof. Then D belongs to 2. Okay. The proof is done. Okay. Everybody understand? We know that every infinite set, for example R, R has a countable set. Okay. Okay. We know that from set theory, every infinite set has a countable set. Let X has a countable, then X has a countable set, like R. I write R here, R1, R2, R3, R4, I5, 8. Okay? We divide R to two sets. Okay? This is the element of power set. We have two cases. D is infinite, D is finite. If D is infinite, from the assumption of theorem, D belongs to 2. Now, let D is finite. Okay? We can write D1 as a B intersection with D, D2 intersection of C and D here. C and D, E and D. Okay? You see that D1 intersection with D2 is D. Okay? You see that A is belong to topology, C is belong to topology. Okay? B and C belong to topology because it is infinite. Okay? Okay? Then D1 and D2, okay? Their intersection is infinite. D1 and D2 is infinite. Okay? D1 and D2 belong to 2. Okay? 2 is the topology. Then the intersection of D1 and D2 is belong to topology. Okay. Everybody understand? اوكي تشکر قصدان الحسابی. Okay, I give you a exercises here. Exercises. I hope you can find a way to do exercises. Okay. Let X be a non-empty set. Let x0 belong to X. Put so x0 is defined as a subset of X such that x0 is not belong to R. Union with show that so x0 is a topology on in this I give you a picture here. This is X and this is x0. Okay, this is x0. We choose subsets of X such as X and there x0 is not belong to R. For example, this is this is this is this is and all of elements of subsets of X okay you show that this is the topology on X. Anybody you know that X belong to okay also the empty set is belong to this I give you okay. As you see X belong to okay, indeed X belong to x0 okay. Also x0 is not belong to empty set, then empty set belong to x0 okay. X and B belong to X. The first condition hold. Okay. Two conditions. The second condition. R1 and R2 belong to x0. Okay. The intersection of, as you see, x1 is not belong to R1. Okay. x0 is not belong to R2. Then x0 is not belong to R1 intersection with R2, then R1 intersection with R2 is belong to x0. This is the second condition hold. You can check the final condition, only final condition. Everybody understand? I check two condition from three condition for you. Only you check the final condition holds for this topology, and then to x0 is the topology. Okay? Okay? You show the final condition by yourself. Okay? Everybody understand? I come back after 10 minutes. Okay? Finite topology. Okay. What is it? Let X be a non-empty set. Put to F. To F from finite, co-finite. Okay, F is come from finite. What is it? The subsets of X that X minus R is finite. Excuse me. X minus R is finite. Union with empty set. Okay? To F is called cofinite topology on X. Okay? We show that to F is a topology. Okay. You see that P, the empty set, is belong to 2. Okay? P, by definition, the empty set belong to 2F. Okay? Okay? If I choose X minus R, X minus empty, then X minus empty. Okay? Uh, uh, X minus X. It is finite. Okay? This is empty set. empty set. This is empty set. Okay. X minus X is a empty set. Then it is finite, huh? Okay. Then X belongs to F. Everybody understand? Okay. X is empty set. Empty set as you see is finite. Okay. Then X belongs to F. Okay. First condition hold. First condition indeed phi and X belong to F. Condition hold. Okay. Let R1 and R2 belong to F. We must show that R1 intersection with R2 belong to F. Okay? By assumption, R1 belong to F, then X minus R1 is finite. Okay? R2 belong to F, then X finite. Then union is finite. Okay? Then what we get? That R1 intersection R2 belong to F. Okay? I come back to the definition. To F here, X minus R is finite. X minus R finite. Then R belongs to F. Then R belongs to F. Okay? Indeed, R belongs to F if and only if X minus R is finite. Okay? Now, X minus R intersection with R2 is finite, then R1 intersection R2 belongs to F. Okay, everybody understand? Okay, تشكر القفاجي, تشكر قسم الحسناوي. Okay. I check the final condition. Okay? Final condition. What is it? Let I, for example, I belong to I. Okay. I belong to F. For every I in I must show that union of I belong to I is belong to F. Okay. I belong to F. From here, for every I belong to R, x minus I is finite. Okay? Every x minus I is finite. Now here, I must show that x minus union of I belong to I is finite. We have, okay, x minus union of I belong to I. So, from set theory, you know that it is intersection of x minus I belong to, okay, okay, and this is a subset of x minus I. Okay, x minus I is finite. This is finite. Then this is finite. Then this is finite. Okay, from here, we understand that the union of I belong to O. Okay, everybody understand finite topology. Okay. Fine. Okay. Okay. We show that cofinite is a topology on X. Is a topology on X. Okay. I give you exercises here. Exercises. What is the exercises? Here. Let X is a finite set. Okay. Show that the cofinite topology is X. Indeed, the power set of X. Anybody, can you show it? Can you show it? Can prove it? We know that, I help you. We know that tau f is a subset of X. Okay. We must show that Px also is a subset of 2f. In it, for every d of x belong to show that x minus d is finite. But we know that this is trivial. This is trivial. Every d from Px. We know x is finite. Px finite. X is finite. Okay? X is finite. X minus d is finite. X minus d is a finite. Then proof is done. I prove it. Understand?